Hey guys, I'm the aforementioned Mads, and I brought a friend today.
I'm Kevin Pilch-Basson. I'm a dev lead on the managed languages team responsible for the IDEs for VB and C#.
And I'm Mads Torgersen. I'm a PM responsible for the C# language design. And we're here today to talk a little about what we've lovingly been calling Project Roslyn. It's something we've been working on for many years. Larry runs through the room. Looks like Kevin isn't on, but if you didn't hear him, he's Kevin Pilch-Basson, and he's a very lovely colleague of mine on the C# and VB team. Project Roslyn is an investment we made over a long time to fully re-implement both the C# and VB compilers. They're now written in C# and Visual Basic rather than in some other language that we shall not mention. We wanted to do them with rich public APIs, so the deep understanding of the language that a compiler has can benefit the IDE, but also benefit third parties that want to use that to look at source code, reason about source code, produce source code, and so on. We also open source now, so it's all the compilers are all out on Codeplex. So you can go look at the source code, and indeed we'll take a quick peek at that a little later in this talk. So we call this API the .NET compiler platform. It's a compiler that you can build on, so it's a compiler platform, and we invite you to check it out. So why did we do this? Typically, when somebody says, "Hey, let's take this huge big thing that we've invested on for half a decade and rewrite it from scratch," what you should do is run away screaming and say, "No, it will never work." We needed some really good reasons for why to do this. When we think about it, really think in terms of the different people who will benefit from this work. Of course, primarily the developers who use C# and VB. We can, by re-architecting and building the compiler from scratch, we can go to the next level of the IDE experience, essentially. We are now at a level of language understanding that we could never really achieve before. And so what you will see is primarily that your IDE is just getting smarter. It's getting slicker and better at understanding what your code is doing to a deep level, and Kevin will demo that a little later. Also, because the APIs are open, we expect lots of people to build their own little features, whether they be IDE plugins or they be static analysis or other kinds of things that make use of the rich language understanding that we're offering up in the APIs. And so we think that there are thousands of people who will build their own little language understanding things. An example, if you look at a company where you have certain rules that you want to enforce around how you write code, well, it's easy for someone at that company to sit down, write a little IDE plugin, a Visual Studio plugin that in a few lines of code, as Kevin also will demonstrate, looks for certain patterns in the code, tells the user with a squiggle, just like a built-in IDE experience, this is probably not what you do, and even offers up a fix to do that. So we expect that many more people will contribute to the IDE experience, contribute to the community or in their company or otherwise. That again should help every developer on the planet. And of course, we, the team, have a new clean architecture to build on. It's easier for us to add new language features and to build new IDE features and so on. And we think our team and Microsoft as a whole will also benefit in being able to provide more value. So this is why we're doing it. And so by open sourcing it, we're really thinking that we're magnifying all of these benefits because not only we in the Microsoft ecosystem, but everyone who's C# based. So take, for example, Xamarin, that's mono-based. Well, now they've announced that they will use the Roslyn source code as a basis for their IDE experience, and so on. It really benefits the whole ecosystem around C#. We think we have a good reason to embark on this project. And for the rest of this talk, we're going to take you on a tour through the different aspects of this, as pointed out here. So first I will hand it over to Kevin, who will demo. We'll do an awkward switch here of places, and he will demo the rich IDE experiences that Roslyn enables, sort of a first look at that, and how you can build your own diagnostics using the Roslyn API. And then I'll come back and I'll talk a little bit about the new language features that we're also building on top of this new compiler framework. So over to Kevin.
All right. Just before I start, I'll pick one of the questions that's up there. The question from Hisham is, where does Roslyn take place in the ASP.NET compilation process, and how does it improve app startup time? So the first part of that, Roslyn basically replaces the compilers, and so in typical ASP.NET applications, that happens at 2 different times. First of all, when you're compiling kind of your app code folder or your .csproj file, and that happens kind of on the developer's machine, and it just invokes CSC, and Roslyn replaces CSC. The second half is when you're compiling individual pages on the server, ASPX pages or CSHTML pages. And the ASP.NET team is looking at building a new CodeDOM compiler that uses Roslyn, and it can help improve that compilation time by kind of caching some of the metadata that we have to import. So for the second question, how will it improve app startup time? If you're talking about a web app, it can improve some of that compilation time. Other than that, Roslyn is not really involved in the app startup time to a tremendous extent, nearly as much as the JIT or .NET Native that Andrew was talking about last time. We did try to make some small improvements to the IL optimizations we do, but it's probably not going to have a significant impact on app startup time. So I'll flip over to Visual Studio now, and I'll start talking about some of those IDE experiences that Mads was mentioned that I would demo. So starting here, I have kind of a simple C# program. It's a program that calculates the area of a circle. It's pretty complicated, but one of the first things I wanted to mention is that as part of Roslyn, Mads kind of mentioned that we rebuilt the whole IDE along with the whole compiler. And so it's important to note that this means that everything that you see that is language specific here has been rewritten. And as we did that, we kind of took the opportunity to try to do things a little bit better than we did before. So one simple example of that is if I invoke quick info and hover over something, you can see that we now show the glyph for the item in the quick info window. We show the colors and that sort of thing. Another small example, if I collapse an outlining region and I get the tooltip there, again, that's actually a projection of the underlying editor buffer, so I get full kind of colors and what I would expect to see there. Moving on, you can see a third thing up here. These using statements are kind of faded out. They're a light gray. That's because they're not actually used in the program. So we've for a long time had this command that allow you to remove unnecessary usings, but you didn't really know whether you needed to invoke it or not. You didn't know if it was actually going to do anything. And so we're trying to provide you with a little bit more of a hint that there's something you could do here. Over to the left in the margin, you'll see there's a light bulb over here. And if I hover over that, or use the smart tag or the keyboard command, Control Dot, you'll see that it offers to just fix that for me and has this kind of lightweight preview over here that shows what the file's going to look like after I'm done. And that's kind of a theme that we've tried to apply throughout the IDE, and I'll show you a little bit more of that later. So first of all, let's go ahead and remove that unnecessary using. We've taken this idea of unnecessary code and we have applied it in some other places, and so I'm going to steal a bit of Mads' thunder by using a new language feature from C#6 here. And so if I put a using system.console up here, this is a static class that exists, so you can just using a static class. And you can see this is kind of faded out because it's not really necessary. But down here, console is also kind of faded out because it turns out I can just refer to WriteLine without having console there if I have the using system.console. And so again, I can use the light bulb, Control Dot to bring it up. I get this preview of what the line of code is going to look like if I apply this fix. And so I'll hit enter, apply that fix, and you'll see just a little bit later as we refresh up here, now this system.console is not faded out because now we're actually using it. So we have this kind of rich understanding of what exactly is being used through your program. So some other kind of IDE improvements that we talked about doing, or that we wanted to implement with Roslyn, are just kind of small refactorings that really help you move your code around, rearrange it, figure out what you want it to look like. So you can see in here, I've got this repeated expression, convert.toDouble. And so if I just select that, and I hit another new keyboard command, which is Alt-Dot to show the list of available refactorings, I have this option to introduce a local for all occurrences of this expression. And it gives me, again, this kind of rich preview of exactly what is going to happen. But not just that, if I invoke it, we get dropped into this new inline rename experience where you can see kind of all of the references are highlighted green directly in the editor. And as I type, it's updated live across all of those references. And then we have this little dashboard up here that tells you some interesting things that are going on. So that's kind of a great visual experience of what's going on. But we went a little bit further than that because we also started to do some detection and resolution of of things that can go wrong when I'm doing a rename. So if I type args here, you'll see these two instances get colored red because that's actually going to cause problems in my program, and there's no way that we can fix it up. If I pick a different example, well, let's just put radius here for now and commit. If I come down here and refer to that, you notice that I have a static field here called radius. Actually, let's rename this just with F2. If I refer to that field in here, beforehand, now if I go ahead and rename this radius to radius, you'll see that now we have a conflict that can be resolved. And you'll see that down here, we were able to actually go ahead and fully qualify the reference to the field so that it works. And so that's kind of another example there. Next thing I wanted to look at was if I, again, select some code here and hit Alt-Dot, we have another example where I can introduce a local here, and let's call this local circle area. And again, we're dropped into that inline rename experience to pick a new name that allows me to detect and find these conflicts, resolves them automatically if it can. But talking about how we fixed up existing features a little bit more, we previously had the extract method refactoring, and we've kind of put that in the same kind of framework. So if I have this selection and I hit Alt-Dot, I can also extract method here. And again, with the lightweight preview, you can see exactly what it's going to do. So in this case, I'm going to invoke it. And again, instead of popping up a dialog to ask for what the new name is, we figured you'd rather stay kind of directly in the code. And so we pick a name for you. In this case, we looked at the code and saw that it was pi times the same thing twice. And so we figured that you must be calculating the area of a circle. And so we suggested that we would name the method getCircleArea.
That's why it took so long.
That's why it took so long. No, the real result is we saw that you were assigning it to something called CircleArea, and so we picked a reasonable heuristic. But again, I'm kind of dropped into this inline rename experience, and so if I don't like that name, I can just type a new one. If I do like it, I can just hit enter, and I can move along with my flow. So again, just kind of trying to stay in the code, have this quick fix-up, some better heuristics. Coming back up here, now that I've extracted that method, I don't know that I really need to have all of these locals anymore. So again, if I just hit Alt-Dot here, I can inline a temporary variable here and just kind of get rid of that. And same thing here. And so it's just these kind of refactorings that you apply manually all the time. Introduce explaining variable, inline temporary variable, extract method, rename. We've really tried to take those and A, add the ones that were missing before, and B, kind of improve on the ones that we already had to kind of keep you in the editor, make the flow a little bit better. So those are kind of just some of the IDE features that we've built that are going to make your lives a little bit better. The next piece that I'm going to talk about is actually the diagnostic piece that Mads was talking about, some static analysis stuff. So I'm going to load a different solution over here called Bracer. And the idea here is, let's say that we want to enforce that on our team, no one can write an if statement that doesn't have braces around it, because there's just been too many issues with that. So in the Visual Studio 14 CTP that came out a little while ago, there's kind of an SDK add-on you can get for it for Roslyn that has some project templates, and they let you create one of these diagnostic analyzers. And they basically look like this out of the box. So I have something that I need to provide an ID, some sort of a description, what is the message that's going to go in the menu, what category is it, and then I kind of say I'm interested in looking at if statements and else clauses, and then I have this method that I need to implement called analyzeNode. And Mads was saying it's not very much code to handle analyzing this sort of thing, and so I'm going to demonstrate that that's true. If I kind of want to look at if statements, I can come in and I'm passed in a node. I can say, I expect that to be an if statement because I said up here that I'm interested in if statements. So if I get an if statement and that if statement has a statement and that statement is not a block, so it's just a regular old statement, then we want to add a diagnostic. And so I can go ahead and Control F5 this to launch another Visual Studio where I'm kind of testing out this analyzer that I built. And if I open that project over here, give it 1 second, you'll see that once this analysis kind of gets automatically picked up and run by Roslyn, that a warning will show up on the 2 if statements that exist here, saying that if statements must have braces. You can kind of guess that font doesn't listen to the settings that I adjusted, so that seems like a bug we should fix. But it says if statements must have braces. It's also kind of down here in the error list, and so that's kind of an interesting thing there. Out of the box, we've kind of built in the ability to suppress this message, and so there's kind of these 3 light bulb entries already saying, no, in this particular case, it's really the right thing to not have braces on my if. But let's go back and take a look at what it would take to actually build that fix. You'll also notice down here I have an else statement that doesn't have the warning on it, even though it does. So let's go back to the other Visual Studio, and let's see if we can, A, add the analysis for the else. So that's actually almost identical to what we had before, except we want to not break nested else if statements. So we check if it's not a block and not an if statement. So now we've handled the else clauses. Come back over to this code fix provider class. This is again provided by the template in basically this form. And we can throw in the code to fix if statements, which just say if I find an if statement, build me a new one where the statement is a block statement with the original statement in it. And it's pretty much, again, the same thing for doing the else. So I'll throw that in and then run it again. Come over here and open this sample project. And again, you'll see that this time the warning will show up in all 3 places, and it'll have the kind of fix associated with it that allows me to just go ahead and add the braces. And again, without me having to write any of the code to handle the light bulb or the braces or running this analysis in the background efficiently, canceling it if the user starts typing again, coming up with a preview. You didn't see me write any of that code. That's kind of all handled by Roslyn. I just wrote a few lines of code that kind of really dealt with the heart of the issue that I'm trying to diagnose and fix, and Roslyn kind of presents it in a unified way. And so I can go ahead and invoke this, and you'll see now I have braces. And same thing with these 3. So I can kind of quickly clean up my code to meet my team's style requirements. So that's kind of the development model of me Control F5ing into it. But that's not where we think people are going to really use these in the long term. So if I go ahead and close this, I'm going to just open a regular Visual Studio that's not in the kind of experimental instance where we've installed that thing to run all the time. And I will, when it comes up, I'm going to open that same project. You'll see that there won't be any warnings. And I'll show you kind of the new way that we're trying to think about this, where these sort of diagnostics are attached to your projects.
So I think the demo you just showed, it really drives home a couple things. First of all, it is really easy to write these diagnostics and fixes. You don't have to be a compiler weenie to do this. It's a tiny little object model, and well, the object model is big, but it's easy to interact with, and the code you have to write is very little, and you get a completely first-class experience out of it. Like, it looks like an IDE feature once you're done. So that is really what we mean by the partners, the thousands that will build on the Roslyn API and enhance the IDE experience, maybe just for a subset of developers that need that particular enhancement.
Okay, so I'm back up and running. So this is kind of my regular Visual Studio. I have that same sample program running. You see that I don't have any warnings here. This is, again, the kind of Visual Studio 14 CTP that we released a little while ago. And so some of you might have noticed that there's this new Analyzers node here in Solution Explorer that's kind of near the References and Properties nodes, and may have wondered what that is. Well, the idea is that I can go ahead and add an analyzer, and this is the output of that other project that I have open. And I can just add this Analyzer DLL to my project, and Visual Studio will then, and the compiler, in fact, will then load the analyzers out of that DLL and show me the static analysis from it and show me the fixes and stuff as well. But this is not just Visual Studio. So if I save this, if I flip over to the command line over here and I actually just build this from the command line, we should also see the warnings show up. Must have a Oh, that was clean. That's why. I should also see the warnings show up right here on the command line build as well. And so if you're thinking about continuous integration systems or any sort of, passing rules along to other people in the team, they don't have to go ahead and configure their Visual Studio to say, oh, install this rule, install this rule, install this rule. If you're a consultant and you're working on multiple code bases that have different rules, we really want these sorts of things to flow along with the rules. And the next step that I didn't show here, that will hopefully be coming in the next TTP that we do, is kind of the ability to have these flow along with your project as NuGet references. And so imagine if you're a developer of a NuGet package, that you could write custom diagnostics about how people use your library to go along with it. One of the examples that we use internally all the time is JSON.NET. Say I am doing something that is parsing some JSON code, and I have a literal string of the JSON in my source file. Wouldn't it be nice if you actually had a diagnostic that told you ahead of time, this is actually not valid JSON, right? And so you shouldn't be trying to use the object model on this. And so we kind of see this across a broad variety of different API spaces, this idea of code-aware frameworks and really having domain-specific static analysis for things. And so those are the demos that I was going to do. Now I'm going to turn it over to Mads.
Okay.
He's going to talk about some of the language stuff. But maybe we should answer
Hand me
a
the
question.
pipe. Yeah, so let's take a little break and look at a few questions. We may get into a situation where we are jumping the shark on some topics that we'll get to, in particular language questions. So I may skip some of those or deal with them briefly. But let's see where we're at. So HP asks, will future versions of .NET support automatic injection of default constructor when we define only parameterized constructors in a class? So I think that suggests that you should always have a no-arc constructor generated for you. I don't think we'll go there. I think there are many reasons why you want to not always have that. The next question I can't actually see all of yet. So while that one scrolls up, let me, before we dive into some of the language stuff, let me show you a good way to learn more about Roslyn, the project, the opportunities you have. A good place to start is the Codeplex site that we have. It's called roslyn.codeplex.com. And I have it up here. I hope you can see the slightly tiny font here. I can zoom in a little bit. So here, obviously, the source code for the compiler lives. You can browse it directly in here, or if you want a better source code browsing experience, you can go to source.roslyn.codeplex.com, which is a website that is generated by Roslyn. So it generates HTML by using Roslyn on the Roslyn sources. So you have a fully hyperlinked website browsing experience. I have it open here on some of the syntax note that you saw, and so here you can see just what is the code for our method declaration syntax node. You can see, for instance, that the properties are all getter-only properties. That's because our object model is completely immutable. All the syntax trees and things you manipulate when you use this object model, they don't change from under you. They stay the same. The next time you type something, you get a new model, and we make sure to keep that efficient.
So for those of you who are watching, Andrew showed this in the last session as well, talking about the .NET Framework reference source code.
Yes.
And so this is basically the same indexing engine that we ran over the .NET Framework reference code and Roslyn. And Roslyn actually has one-way links into the .NET reference code. And so if you click on String Builder or something like that, you'll actually get into that other site.
Yeah, if we can find I can't.
People trust you.
Okay. Yeah, I can't find something right now that, but yeah, these are linked together. And this is just an example of something else you can build with Roslyn that was relatively easy for us to build because there's a full code analysis framework at your fingertips as an API. If you go back here quickly to the Codeplex site, you'll see that there's tons of documentation. One of the things we really do want to do this in the open and get as much community feedback as possible. So one of the things we do is to put our language design notes, the C# and Visual Basic language design notes out here. If I click on this, you can see that here are notes for all the language design meetings we've had. These are the same notes that we use internally to keep track of our decisions in the language design team. They're right out here actually as a discussion topic in public. You can go see what we thought, and people can go and comment and tell us how stupid we were or how brilliant. I recommend a bit of both if you want to go here. And this way we have a very direct conversation with the community about the evolution of the language as well. Let's look at a few more questions and then go look at more language features. So Will says, will there eventually be a push to have Roslyn eventually support other languages, to support languages like Boo, Nemoli, or F#? Well, that's a good question. We made a very conscious decision when we did Roslyn to not have it be a sort of generic compiler framework for many languages, because we also wanted to get done. We wanted to get to value quickly, and we also didn't want to end up in a place where we had a lot of abstractions in people's face that weren't really relevant for the language they're working on. So there's actually two Roslyns, there's C# and VB compilers, and they're separate APIs, but of course they're architecturally similar. We have the same people building the same elements of both, and so they're staying very much in tune. Whether we should go and apply some of Roslyn directly to other languages, that's an open question. Other languages have certainly learned from Roslyn and are using kind of some of the same architectural principles. TypeScript comes to mind, for instance. So one way or another, the sort of Roslyn style way of doing things is probably going to spread a little, at least within the Microsoft ecosystem. And since the code is open source, other people are welcome to do that as well.
Yep. You know, Matt said we deliberately scoped it to C# and VB. With that said, there are some kind of language neutral primitive types in the system, and we tried our best in designing those to not kind of lock ourselves into only supporting C# and VB.
Right.
And so, so I think it's conceivable for people to add other languages. Whether or not we'll do it, probably not, because we're mostly the C# and VB team. F# was up there, and our team actually does own F# as well. F#'s an interesting one in that it's a .NET language, and it's a managed language like C# and VB. It turns out that the type system in F# is different enough that at least at the semantic level, the kind of Roslyn APIs aren't a great map for F#.
Also, you got to remember, F# already has a pretty great compiler written in itself.
Right.
And we were lacking that in C# and VB. So we were kind of actually taking another cue, like we often take cues from F#. It's where we learn about doing new things, and then we go and apply it to our bigger languages. And this is a case, again, where F# was already in a pretty decent place. It's not as elaborate an API as Roslyn turned out to be, but it's a lot better than where we started from. Yahor says, what is the next big thing in the C# after Roslyn that is actually compiler and not a language feature? So the next big compiler feature?
I think he means Roslyn is actually a compiler, not a language feature.
Oh, I see what you're saying.
So what's the next big thing in C#?
Yeah, we'll talk about a few language features in a bit. I can sort of introduce that right now by saying language features weren't the main thing for the Roslyn push, so these will be smaller language features than maybe you're used to. It's not your link or your async. So there are smaller features here, and for future bigger features, I think that we'll wait and see. We're not quite there yet where we're ready to make decisions on that. When will this new IDE be available? The next version of Visual Studio.
Soma said in his blog when we announced the Visual Studio 14 CTP that we're hoping for early in 2015.
Right. Well, if he said it, we can say it too.
That's right. That's why I said his name first.
So it's definitely, it's now. It is the next version. That's one thing to note. And when that exactly is, well, we're hoping that early 2015. And one more question from Anthony. Can you switch these new features on and off depending on how you like to code?
I guess it depends on which features we're talking about.
Certainly the
diagnostics.
The diagnostics can be turned on and off. The things that are built in, these are really like the new rename experience, for instance. That is the way you rename now. You're not going to get the old one back. We think we are making all of these experiences better if they don't stay the same, and so we don't actually give you a choice to go back to having modal windows or something like that. Right. Yeah, this is the new way. Sorry if you like the old one. Okay, I think let's take a break from the questions and look a little bit more at language features.
Yep.
So I'm going to go into Visual Studio, no surprise here, and talk a little bit. First, let's take a quick look at some VB language features, and then some C# ones as well. So first of all, we've had this philosophy called co-evolution for a while, which essentially states that every significant thing that makes sense in both C# and VB we will do in both C# and VB. And we'll also keep catching languages up to each other where one feature is missing that should be in the other language. So here are a few examples of some very basic but really annoying things in VB that have been missing that C# has. So one of them is the ability to add comments after new lines when you have implicit line continuations here. Oh man, how annoying is that not to be able to do that? So we're fixing that. Also, multi-line string literals, an obvious thing here. So these are just a few parity features. There's more, but this is the set I chose to show you here. Then there are some features we're considering for both languages. Here are some little ones again around integral literals. First of all, we're thinking to introduce binary literals. So what you're seeing here is and B in VB. In C#, it's going to be 0B. And it'll allow you to introduce binary directly. Like why force people to decode in the mind from hex or something like that? Just show the bits directly. It's the intention. We also want to introduce the ability to just have digit separators. We're thinking to use the underbar character for that. You can put it wherever you like in your literal. Just whichever way you want to group your digits so that it makes sense to you. So tiny little syntactic things, but hopefully useful. One thing that we're considering for VB specifically is a feature that would fit well into VB, but maybe not so well into C#. C# has its switch statement, and VB has its select case statement. And select case is actually a lot more general than switch. It's more of a kind of fancy if. So you can have fancy things like ranges and so on in your cases, where C# only has constants. And that makes it a good fit for adding a little more logic to those cases that can be very useful. One thing in particular is type casing. So allowing a case to say that if the value I'm switching on or selecting on has a specific type, then give me a name for the value with that type inside of my case body and let me use that directly. So I'm switching here or selecting on shapes. If that happens to be a circle, well then I can give that a name, C, and in the case here I can access circle-specific things like C.radius. So a type switch really built in to the select case of VB. Also here you see another aspect where a case statement has a condition on it. So we're saying case R is rectangle when it is also not a square, which is a little artificial here. We could just have put it after the one that handles square. Sure. But again, to show that there's more expressiveness here to be explored, and that kind of just fits naturally in. We're hoping to get this feature into the next version of VB. Now I'm going to switch over to C#, and let's see what we have here. So Kevin already did show a language feature, the ability to add usings for types. So if I put a static class here using system.console, or that would be a common one. I think an even more useful one is using system.math. But generally, when you have static classes that are mostly about a collection of functions, when you need those functions all the time in a piece of code, it's annoying to have to prefix them all the time with the class name.
If you're using the Roslyn API, Syntax Factory is a great example.
Yes. Yes, so Roslyn itself is a place where we experienced a lot of this. So if you look here, now console is grayed out. I get the light bulb, and it allows me to simplify this type name or actually simplify all the type names. So I have an occurrence of math in here as well, and make this go away. So if you look at the code I have here, it's very simple code. I create an array of points. I have a point class. I turn them, I write them out. I turn them into JSON using JSON.net. Write the JSON out, and I turn that JSON back into points, and I write that out. So that's all it does. So I'm going to run it once and probably not again. It's going to build because I changed the code. It's going to succeed, and here you see the points written out. So very simple app. But now let's go and actually look at the point class that I have and some of the things about it that are currently a nuisance using the current version of C# that we're going to clean up. I want to say that a general theme of our language features this time is not to introduce new mental baggage, essentially, but to just kind of crisp up some of the syntaxes you use a lot, maybe get you in a little more declarative direction. with how you code. And in particular, we want to try leveling the playing field between mutable and immutable types, where that has been kind of skewed in the past. So this is an example of that. I want to show you how we're making this better. So first of all, this should be familiar to you. I want my point class to be immutable. So today I have no option of using auto properties because they're get set. So I have old-fashioned properties with a manually written getter. I have some backing fields that are read-only, and I have a constructor that initializes those backing fields. That's a lot of repetition and a lot of lines of code here. So what we want to allow is a few different features that kind of combine to make this a better experience. The first one being, I don't actually want to write this constructor directly. It's always the case that a point is created with an x and a y, so I want to kind of state that up front on the class itself. We call that a primary constructor. So we say that point has a primary constructor. It always takes an x and a y. And then this puts the x and a y into scope for initializers in the class. So now x is in scope here. I can initialize the private variables here directly with x and y, and I don't actually need this constructor at all. I just wrote that whole constructor just like that. Take some parameters directly on the class. Those parameters are in scope when I initialize. Just initialize the fields directly, and that whole bulk of the constructor declaration goes away. I want to take it a little further. I'm kind of annoyed that I can't use auto properties because I'm getter only. So let's imagine for a second that I do what legions of people have done, and I give up on my getter onlyness because I want the shorter syntax, and I make it an auto property, and I just cross my fingers or put a comment that people don't modify the object after.
You could at least make it private set. Yeah.
I could make private set. That would be a way to do it. So what we're also going to allow, so now we have backing fields, and we're actually going to allow you to initialize auto properties directly. So you can put an initializer after the property body there, and initialize them directly. And now you don't need to manually declare your backing fields either. But of course, this was at the price of now having setters. So the last thing we're going to do in this vein here is to actually allow you to have auto properties that don't have setters. Because now you can initialize them, and we're actually also going to allow you to assign to getter-only properties in the constructor.
Treat them kind of like read-only.
So treat them like read-only fields, essentially. Now we allow you to have getter-only auto properties that can be initialized or assigned in the constructor, and they don't need the setter anymore to get a value in there in the first place. And whenever you have a getter-only auto property, the underlying backing field that the compiler generates is actually read-only. So we notice that it's getter-only, we generate a read-only field, so that through reflection and so on, it actually is the read-only field that you would have written manually.
Great.
So look at this now. That kind of boiled it down quite a lot, didn't it? So that's one theme that we're pretty happy with. I think a lot of classes have this pattern of just one constructor, a few things are initialized by it, maybe things are passed to a base constructor. You can also do that using primary constructors. Let's say I have an imaginary base class here, C, that I want to use, probably not console, but and I want to pass the sum of x and y to that. Well, I can do that directly when I specify the base class. So the syntax is kind of natural for that. So that's that set of features. Let's go and look at a different, let's first delete this because it doesn't compile. Let's go look at a different few features that we're thinking to add here. Here I have some ugly code. This is where I take a sequence of points and I turn it into a J array. And it's kind of ugly because I have to do it very imperatively. Well, first it's ugly because I don't have braces in my if statement, and apparently I enabled the diagnostic that Kevin just wrote. So so let's start out by actually following his advice here and adding the braces. But it's also a bit ugly because I'm very imperatively building my object here. I have a for loop, I create J objects, and then I assign into these indices. They're sort of like, the J objects are sort of like having an X and a Y field, but not really. And so the way you interact with it is to use indexers. But if they were real fields, what I would do in C# would be to initialize them with an object initializer, which is more declarative I'm sort of doing the object construction in one expression. So this is really what I would have wanted to write if they were really members x and y, but they're not. However, we want to add the ability to also initialize through indexers in object initializers. So what we'll allow you to do is to actually say that at index string x here, put p.x, and at index y, put p.y. So adding the ability to initialize to indexers as well as to members in object initializers.
You got a single quote.
I got a single quote there. That's why things are looking a little strange. There we go. Okay, so now I created my J object in one expression rather than several. And now this kind of declarativeness kind of balloons. So even now with existing features, because I can create my J object in one expression, well, first of all, I don't actually need to put it in a temporary variable here.
You can alt dot.
I can just, what's that?
You could use alt dot to inline the temporary variable.
I guess I could, yeah. I should have done that. But to the old-fashioned way, I can just add it directly to the result. And actually, now that I think about it, instead of imperatively creating the list here, I want to, for some reason my ID is getting slow. That's probably something Kevin will have to look into.
Yep.
I could just actually pass to the JArray the result of writing a link query. So instead of for eaching over the points, I can from p in points. Let's do that. And I don't want the null ones. That was my if down there. So I just say where p ain't null using the ain't operator in C#. I can just select. And now because I am creating the object with one expression, that is, because of this new feature, that is what allows me to now just put a select clause here that directly creates the object and returns it. And so instead of the whole for each and temporary variables and stuff, I am now just creating a sequence of J objects and passing that sequence directly to the JArray constructor. So I don't actually even need the result variable anymore. I can just return, and I have a very declarative, sort of structurally clear description of what I'm doing. So generally, when you do things at the bottom, it kind of bubbles to the top. This is a nice thing. Okay, next feature. Here's where I go the other way. I have a JArray. I want to turn it into an removal of points. So I have, again, I'm being imperative here. I'm not going to, I could actually fix that too, but I'm not going to this time. The thing I want to home in on is this place here where I want to take things, I want to really try to get something out of a J object at index x and treat it like an int. So I have a helper method for that, and it uses the common try pattern. It's a try get int. So what it will do is it will return true or false depending on whether it could get it out as an int. It'll try to, if it's a string, it'll try to parse it and stuff like that. If it really couldn't, it will return false. Otherwise, it'll return that int as an out parameter. Out parameters are really useful, in particular in this pattern. But the really annoying thing is I have to declare those variables up front. So there's an extra line of code there. That gets annoying. Wouldn't it be nice if I could just declare a variable right in line where I need it? And that is the next feature I'm going to talk about. We call that declaration expressions. And that is simply a feature that allows you to write a variable declaration right in the middle of an expression, as an expression. It's an expression that declares a variable and evaluates to that variable. Okay, so here I'm creating a variable x, passing it as an out parameter. I can do the same for y. And now I don't need to declare them up front here.
Can I use var there? Can I use type inference?
That's a great question. So first of all, var is generally allowed if you give an initializer on the variable. So if I set equals 0 here, then it could look at the initializer and say, oh, it's int. And that certainly works. But we're actually taking it a step further here and saying, well, I'm passing this as an out parameter to something. So if the compiler can figure out what that something is, we can look at the expected parameter type for that out parameter and say, oh, it's supposed to be an int. Let's just infer from that then. And so you can actually write out var x here. Nice if you have long type names or generics. So we allow this syntax here as well. The x and y introduced inside of the expression like this they're in scope in a meaningful kind of scope here. These are introduced in the condition of an if body, so they're also available in the in the condition of an if, so they're also available in the body of an if. And they're kind of sensible scope rules for how these declaration expression variables are available. Good. And now because of this, I could go and turn this into a LINQ query also, but I'm not going to. Instead, I want to quickly point out a few more features. Here is some code, and I have to say is slightly fake code here that that has a try-catch finally, where we're trying to read the JArray in from a file. And we want to do it asynchronously, so it's an async method, returns a task of JArray. And that's nice. I can use await. I open asynchronously. I read asynchronously in my try block. But what I couldn't do so far is in a catch block, and finally I can't await stuff. So right. if I call here, for instance, I call repository. Oh, this is slow. Repository dot. I want to log that I had an exception here. Log async. I can call that, but I cannot await it in the current version of C#. And what we're simply allowing is that now you can await inside of a catch block and a finally block as well.
Great.
Which is, people have very painful workarounds for this. That's because it is painful to do. We implemented it. It was painful, but it was our pain, and we've done it once and for all, and you don't have to worry about it anymore. Could also mention exception filters. We're actually allowing you to filter exception. So if I'm catching repository exception here, I may only want to catch it under certain circumstances. So now I can put an exception filter on here. I can say if, for instance, e dot, it has an occurrences property somewhere here. Yep. If e dot occurrences is greater than 3, so if this happened a lot, then I want to catch this exception. Otherwise, I want to ignore it and let it keep flowing. This is different from catch rethrow in that the exception keeps its original throw point, and it keeps the stack alive from where it came from. Last tiny feature I want to show, we have 10 minutes left, is what some people, for some reason, call the Elvis operator.
Yeah, I had to ask why it was called that.
I think it has something to do, maybe you'll see it when we get to it. The idea is lots of things can be null, primarily thanks to this guy, Tony Hoare, who's a very famous computer scientist who claims, probably rightfully, that he invented the null pointer and that it was his billion-dollar mistake. So the problem being, of course, that if I call this inspect method with a few persons and then null, then I will get a null reference exception when I get to the null thing. And checking for null at all the right places is really annoying. So we want to make it less annoying by allowing you to do kind of a null conditional dot operator. So this is the Elvis operator, the question dot here. And it kind of looks like Elvis because of it's two dots for eyes, and then it's sort of some hair that curls up. So that's why people call it the Elvis operator. What this means is, check if person is null, and if it is, then kind of short circuit the whole thing here, the whole chain, and just evaluate to null. So when we do this, it'll actually work fine. It'll just print nothing for the last one because console.writeLine works on null.
Great.
I think you'd frequently use it in connection with the null coalescing operator, so that if it's null, then provide a default value. So in this case, we'll just say the length is -1 if the thing weren't there, and it'll print that out instead. Now, what I said is it kind of short circuits this thing here. So even if person was null, we will never go and actually do the length access. But what if person wasn't null, but his first name was null? And let's do this to Tony Hoare, since he brought us into this mess in the first place. If I go do this, then I'll still get a null reference exception because person wasn't null, so I'm going to dot into first name and then dot into length. And of course, to avoid that, you can chain these guys and keep asking for null in cases where they could be. So that's it for language features that I'm going to show. We can go back briefly to the slides here, but I think the main point, I can project this one just to make these points, and then we can take a few questions and take it from there. This is really just a call to action. You've seen a bunch of stuff here. Use the new IDE experience and the language features and give us tons of feedback on the Codeplex side or elsewhere. try these custom diagnostics. It's surprisingly easy, especially with the templates we have that let you F5 into the IDE and so on. Maybe you want to play with your own language features if you have some time on your hands. Fork the compiler source, play around, maybe make a little compiler feature or something like that. Above all, give us feedback. Tell us what you think. Tell us what we should change before we ship this thing and can never change it again.
Right. And there's kind of two places where you can go get this to play with it. You can go get the Visual Studio 14 CTP. That kind of has our latest bits in it. There's also, for people who don't want to install a giant CTP of Visual Studio, there's a preview that we released at Build for VS 2013. So you can kind of do that lightweight install and kick the tires a bit, although that one won't be updated going forward. So if you want to see the changes as we go forward, you need to get into the VS 14 CTPs to look at those.
A set of language features are a little different too, and so on. Things are evolving. So Edward asks, will Roslyn allow things like evaluating Lambda expressions in the immediate window?
That is something that we're working on right now. We're kind of playing with some new debugging APIs from the debugging team and the CLR team. We recognize that this is one of the top items on user voice, and so it's under active investigation right now, and we're hoping we're going to be able to do it.
Right. It's not just one that we can fix with Roslyn. It's an interplay between the compiler and the debugger, so there's work on both sides, and that's what we're looking at. Some of this UI experience has been already available through ReSharper add-in. That's true. So the ReSharper, so it's not that we're necessarily inventing some of what we put in are new interactions, but we're not really trying to be innovative as such. We're just trying to improve the experience. ReSharper has great features, and a lot of those features are because they have a really cool analysis engine for the language. Unfortunately, it's their analysis engine, and it's hard for the rest of us to use it. And so they may be able to do things that you still can't easily do on top of Roslyn. It's a very specialized feature, but a lot of sort of low-hanging fruit people can now start exploiting. We can, and other people who are building on the Roslyn.
Right, and so if we take a look at our telemetry, we find that while ReSharper is a great option for those who have it, statistically, the people who have it are in the minority, and we kind of want to make it kind of raise the bar for everybody who's using C# and VB. And so we're trying to bring some of those key features to everybody. I think there's plenty of room for innovation in IDEs, and so I don't think JetBrains is all that worried that we're going to eat their lunch. Right.
Anthony asks, are there similar features for VB? That is generally the case. There are a few things that, if we look at the language features, there are a few things that I showed that don't make so much sense in VB. I don't think they're going to do the primary constructors. But we are generally trying to put the features in both. So most of what I showed is also going to be in VB.
I think the next one's also a language one.
Will field parameters and primary constructor make it into next C# version? Primary constructors will. What you call field parameters is something we tested out and generally got. So it is in the public end user preview, but we're actually going to take them out. We thought that was probably a step too far, so I'm not even going to explain what they are. Those are going out.
What about style cop on Roslyn? Great idea. Somebody should do that. It's just about all the style cop rules that I've looked at would be pretty easy to implement using Roslyn as an analysis engine. So you could get them kind of live in the IDE as we talked about. You could write fixes for them. It's probably not something that our team is going to have the bandwidth to do. I know I was talking to at least one person who was looking at starting to do some of these, and so hopefully he'll get his kind of initial ones published, and we can build a community around implementing those.
Christoph says, any news on Joe Duffy's C# for systems programming project? No, I don't have news on that. That's Joe Duffy's project. You should ask him.
Those analyzers are awesome for governing coding standards. Will you release a set of analyzers that enforce the official MS?
Probably says coding guidelines or something like that. We can't see the last line.
So as far as I know, there aren't any official MS coding guidelines at the style level. There's things like FXCOP, and so if you take a look at the Codeplex project, we haven't enabled them by default, but we are looking at implementing some of what we consider to be the most useful and most used FXCOP rules as these kind of Roslyn source analysis. And so we have a bunch of them already kind of implemented in the open source repository that you can go take a look at.
Right. One of the things we want to try to do with those is as you choose your preferences in Visual Studio, like do I want the curlies at the end or on the next line, stuff like that, we'll try to respect those also in the diagnostics so that so that you get a similar sort of customizability.
Vishal asks, Roslyn supports VS 2013. We released a preview of Roslyn that supported VS 2013 at Build. That's kind of the download that I mentioned. Going forward, we're not likely to update that unless there's some hugely compelling reason.
Right.
Internally, we're trying to do some coordinated work with the Visual Studio team and the CLR team to improve things like the light bulb experience on the Visual Studio side, the error reporting experience around these kind of diagnostics, and on the CLR side, things like edit and continue and some performance things in the garbage collector. So we're really kind of working with the whole ecosystem at Microsoft, and so it's not likely that there'll be updates for Roslyn that target Visual Studio 2013.
Okay. Is there a plan to make Roslyn OS independent?
I can take this again. We're not actively working on making Roslyn OS independent. What we are working on doing is making the core analysis libraries into portable libraries that target kind of the modern frameworks like phone and store and desktop. We actually checked that into the open source repository earlier this week. In conjunction with that, we talked about Xamarin and kind of the partnership there and them talking about building an IDE. We also have some pull requests from some of the developers on the compiler at Xamarin to allow the Roslyn compilers to run on Mono, and so we've been working on accepting those pull requests. I think we have 2 more in the pipeline that we're working on.
That's a direction we definitely want to go in. If we want to take it seriously that this is the C# compiler for all, then we need to get those OS dependencies all the way out of there.
Yep.
I think this is the last question we have time for. Gooby asks, any language support to make implementing immutable models easier? If I understand the question correctly, then I think I just showed that. If by immutable models you mean immutable objects?
Unless it's like immutable like view models for XAML and that sort of thing.
Right.
Which is hard from a sample data perspective and that sort of thing.
There I don't think we have something for you.
No.
Okay.
Okay, you're supposed to mention what the next talk is.
I'm supposed to mention what the next talk is, so they gave me this beautiful post-it here, which says, Building Universal Windows Apps with SAML and C# in VS. And Larry Lieberman is going to come in here in just a few minutes and tell you all about that. So thank you very much. It was a pleasure to be in your living room or wherever you are, all around the globe. Thank you very much. Download the stuff. Have fun with Roslyn.
Thanks, everybody.